Part F of number 33, of number 19, sorry, assignment 1 says to calculate the range and interquartile range. So let's look at where we can find help for this. It says in page 6. So let's check it out. The range is a statistic. It's a number that we are going to calculate. Just like how we calculated the lower quartile, the median, and the upper quartile, all three of them are descriptive measures, numbers to describe the data set. As you can see, when you calculate the lower quartile, you start talking about the data set. 25% of the values are below the lower quartile, 50% are below the median, and 75% are below the upper quartile. You're using numbers to describe a set of numbers. So these numbers that you are using to describe a set of numbers, these numbers are called descriptive measures, descriptive numbers. And since we calculated them from a sample, they are called statistics. So the range is another descriptive measure. It describes the data set in a different way than the quartiles. The quartiles partition the values into the first quartile, second quartile halfway, and the third quartile 3/4 of the way. The range is another way to describe the data set, another descriptive measure, another statistic. It is a stepping stone into numerical analysis that embraces simply to calculate, okay, the difference between the highest value and the lowest value. The range is equal to the highest value in that data set, subtract the lowest value. What is the difference? What is the range? As you can see, it's different. It's a different description from the quartiles. The quartiles giving you boundary lines from that below, from that below, from that below. But the range gives you the difference between, you know, how wide, how separated that the values are from each other. Very simple calculation. So it appears in this data set, the highest value was 41 years and the lowest value is 16 years. So the range of the ages is 25 years. So taking a second look at the stem and leaf, because the values were presented using a stem and leaf, they were organized using a stem and leaf. As you can see, the highest value is 41 and the lowest value is 16. So the range is 41, subtract 16. Difference between the two. Youngest is 16, the oldest is 41. Now the interquartile range is another descriptive measure that describes how different the values are from each other, but it is not using the highest and the lowest value, it is using the upper quartile and the lower quartile. So it's a little bit more inside of the values itself. Okay, interquartile range. And I must point out that most of the values, the majority of the values are normally encountered within the quartiles. You have a data set, so within the lower and upper quartile, that's where you'll find most of the values in any data set. The quartiles actually follows the number of the actual values where they are. So it's good to have the interquartile range, the difference between all of those numbers, most of those numbers within that section, within that quartiles. You have numbers deviating from them, the lowest and the highest, but the majority are encountered within the quartiles. And you're going to see that now visually using the box and whiskers diagram. Okay, but I just need to point that out there. So the interquartile range is basically the difference between the upper and the lower quartile. So in that case, the upper quartile is 25 years and the lower quartile is 17 years. In that case, you will calculate it up there. As you can see, the upper quartile is 25. The steps are given and the lower quartile was 17. 25 minus 17 will give us the interquartile range, which is 8 years.